Friends, welcome to this class. In last class we discussed about precipitation titration, right? In this class let us discuss about this redox titration. See, redox, red means for reduction and ox stands for oxidation. In a cell where both oxidation and reduction takes place is nothing but redox titration. In this titration both oxidation as well as reduction takes place. See here, for example, in our burette I have got K2Cr2O7 which is yellow in color, right? This is K2Cr2O7, and also in this conical flask I have got this Fe2 plus solution 10 ml I have taken, let us assume. See here, this K2Cr2O7 is a primary standard. Primary standard means whose concentration won't change with the time. So what I will do, I will prepare some concentration of K2Cr2O7, right? So once I prepare this K2Cr2O7, I fill it up in burette. So I know its concentration. So concentration I know in terms of molarity, or we can in terms of normality, right? But there will be difference in molarity and normality. Here 1 molar K2Cr2O7 will be almost equals to 6 normal K2Cr2O7. This is the case. Whereas in case of HCl or NaOH, 1 m of NaOH is equal to 1 n of NaOH, right? But in case of K2Cr2O7, 1 m of K2Cr2O7 is equal to 6 n normal of K2Cr2O7. Why this is so? Everything these things comes in basics, you know, but then also let me explain. Here, see here, one more thing, why this is called redox titration. So here I have taken K2Cr2O7 in burette and Fe2 plus solution in the conical flask. See here, this K2Cr2O7, I can also, K2Cr2O7 can also be written as Cr2O7 2 minus, right? Because if I remove 2K plus, I will get 2 minus. This will react with 14H plus some electrons. I will balance it. How I will balance, you get to know. 2Cr3 plus, right? This is the reaction you need to know. See here what happens. Let me see the oxidation state of this chromium. See here, 7 to the 14, right? 14. Since I need to get 2 minus, so let me minus, so it will be 12. You know how to find oxidation. 2 times of X plus 7 into 2 is equal to 7 into oxidation of oxygen is minus 2 is equal to, I need to get minus 2, right? So 2 times of X, if I take 2 common everywhere, I will get X minus 7 is equal to minus 1. So X is equal to, if 7 goes there, it becomes plus 7, minus 1 is nothing but plus 6. So oxidation state of chromium is plus 6. Here it is getting converted into plus 3. See here, from plus 6 to plus 3, change in oxidation state is 3. But for 2 molecules, here see here, if I balance Cr2 to Cr3 plus, so the change in oxidation state per molecule, here for 2 molecules it's 3 change in oxidation state from plus 6 to plus 3. So change in oxidation state is plus 3 for 2 molecules. For 1 molecule it will be 2 times of plus 3, that is 6. See here how the change in oxidation state is plus 3 for 2 molecules. For 1 molecules it is into 2, it will be around plus 6. Here from plus 3 to plus 6 to plus 3, change in oxidation state is 3 for 2 molecule. For each molecule, change in oxidation state per molecule is nothing but, since 2 is there, no balancing into 2 times of plus 3 is nothing but plus 6. So see here, it is having plus 6 oxidation state. If I add plus 6 electron, here 2 molecules are there, 2 molecules each of plus 6, total plus 12. If I add plus 6 to this, it becomes plus 6 here. 2 into 3 plus is nothing but plus 6. So since it is plus, more plus means we need to add electron here, and I got 2 Cr3 plus. How to balance H2O? Just it is 7 H2O. See here, 14H plus 7 oxygen, 7 H2O, 7 oxygen, 14H plus I got. This is the balanced equation. So what is happening in this reaction? K2Cr2O7 is getting electrons. If getting electrons means reduction. I can tell with the help of getting electrons, or or also I can tell from higher oxidation to lower oxidation state is nothing but reduction, right? So this is reducing. What happens with iron? See here, Fe is there, Fe2 plus. So as soon as I add K2Cr2O7, this will convert, Fe2 plus will convert into Fe3 plus 1 electron. So total 6 electrons are involved in above. So let me multiply by into 6. So net reaction is here. 6 electron cancels here. So here the net reaction is Cr2O7 2 minus plus 14H plus 6 Fe2 plus gives me 2Cr3 plus 7H2O plus 6 Fe3 plus. This is the net reaction. What all happening in this reaction? This is reducing. See here. What about iron? From plus 2 oxidation state to plus 3. Increase in oxidation state. So it is oxidizing. So reduction is also taking place. Oxidation is also taking place. Hence this total reaction is nothing but redox reactions. Right? This total reaction is redox reaction. This thing, balancing of this thing you should understand. Right? How easy, right? See here how I balanced this. The change in oxidation state is plus 3 for 2 molecule. For each molecule it will be plus 6. So I added plus 6 here. Why I added only here? Because it is higher oxidation state. Higher oxidation state to lower oxidation state. It occurs only when it gets electron. So I added electron here. Balancing of H2O can be easily done. Since here 7 oxygens are there, I added 14H plus so that I will get 7H2O. 7 into 2, 14, and 7 into 1, I will get 7 oxygen only. So I balanced like this. This thing is also easy. Since here 6 electrons are involved in above reaction, here only 1 electron is involved. So I multiplied into 6. So once I got everything, I just LHS side one side, RHS side one side, this electron got cancelled. So this is the net reaction. Similarly, here primer student, if I take KMnO4, KMnO4 is also a good oxidizing agent. This is called K2Cr2O7 and KMnO4 called oxidizing agent. It is because here these are undergoing reduction, making other one oxidation. So these are called good oxidizing agent. Those will undergo themselves reduction, making other oxidation. See here, this is undergoing reduction by themselves but making iron other oxidation. So these are called oxidizing agent. So KMnO4 is also an oxidizing agent. But difference between K2Cr2O7 and KMnO4 is, see here, K2Cr2O7 is a primary standard whose concentration won't change with the time. But KMnO4 is a secondary standard whose concentration changes with time, right? So its concentration changes, right? Because it may absorb the moisture from the atmosphere. So second standard. And I told K2Cr2O7 is the yellow in color, whereas KMnO4 is violet in color. That's a two different. Here also to determine the endpoint, as we keep on adding, it will convert Fe2 plus will convert all Fe2 plus converted to Fe3 plus. Then how to determine that end point when all Fe2 plus converted to Fe3 plus? So here also we use indicator. Those indicators are called redox indicators. For example, diphenylamine. Similarly, the principle of redox indicator, everything I will explain with the video. But now let me explain briefly. See here. First Fe2 plus solution was there. When I will add few drops of diphenylamine indicator. So diphenylamine indicator will be colorless initially. When I keep on adding K2Cr2O7, Fe2 plus started converting into Fe3 plus, and this K2Cr2 converted starting to 2Cr3 plus, right? So it is undergoing reduction and this was undergoing oxidation. As soon as all Fe2 plus converted to Fe3 plus, right? One drop excess of K2Cr2O7 will oxidize this diphenylamine, right? So it will oxidize this diphenylamine. So initially the color of diphenylamine is colorless, whereas after oxidation of diphenylamine it will be violet or blue color comes, right? Once the blue color comes, we stop the titration. It means the end point is reached. In this how we determine the end point of redox titration. So I discussed about everything, right? See here, one more thing. Here I told molarity will be 6 times of normality, because see here, molarity means mole per liter, whereas normality means equivalence per liter. That's the difference. If you those comes in basics, see here, easy. See here, 1 m is nothing but 6 times of n. It is nothing but like see here, molarity is always greater than normality. One thing you remember, molarity is equal to A times of n, where A is change in oxidation state per molecule for redox reaction. See here, since change in oxidation for per molecule is 6 here, for per molecule change in oxidation is 6, so molarity will be 6 times of normality. Whereas in case of HCl or NaOH, see here, HCl, acid base reaction, H plus Cl minus. Here molarity is A times of normality. For redox reaction, I called this A as change in oxidation state per molecule. For acids, the A will be basicity. For HCl, it can give only one H plus, so one conjugate base is formed, right? So its basicity is only 1, so M is equal to 1 times of N is nothing but 1 normal. For NaOH will give Na plus OH minus, right? So M is equal to A times of N. For base, it will form Na plus. Na plus is a conjugate acid, so it will give 1 OH minus. So acidity, for base acidity will come. Acidity is 1 for NaOH. So M is equal to 1 into N. So here molarity is equal to normality. Here also molarity equal to normality. Here molarity is 6 times of normality. If you do the calculation, you will get to know. This is how this all comes under basics, but then also I explained, right? And also let me write the reaction using KMnO4. These reactions, how to write, how to balance, everything you need to know. And also this normality, how to convert into molarity, these things if you know, then only you can easily solve the problems, right? And also see here, KMnO4. Instead of KMnO4, I can also write as MnO4 minus, if I remove one K plus, right? So what happens? It will get 4 oxygen means 8 H plus, let me write, in acidic medium, plus what happens? How much electron? Let me give the space as it is, because I need to calculate. So I will get Mn2 plus here. So let me calculate the oxidation state. X plus 4 times of minus 2 gives me minus 1. So X is equal to 4 to the minus 8. If it goes plus 8 minus 1 plus 7. X is equal to plus 7. See here, manganese from plus 7 oxidation state to it is going plus 2 oxidation state. So change in oxidation state is 5 electron. So let me write 5 electron. See here, change in oxidation state per molecule. See here, 1 Mn, so 1 Mn. Change in oxidation plus 7 to plus 2, 5 electron. Whereas in K2Cr2O7 it was 2 chromium. So 2 into plus 3, change in oxidation state was plus 3. So to calculate for each molecule, we need to multiply by 2. So change in oxidation state for per molecule in K2Cr2O7 was plus 6. Here it is plus 5. This is the balanced equation, right? Plus, let me balance water, this hydrogen and oxygen as a water. 8H plus 4, so let me write H2O, right? 4H2O. See here, hydrogens are also balanced, oxygen are also balanced. If I have a same Fe2 plus solution here, similarly Fe2 plus is oxidized to Fe3 plus. Oxidized means removal of 1 electron, so 1 electron is left, or also increase in oxidation number. Here decrease in oxidation number is taken place, so it is reduction. Since it is undergoing reduction, making this one to oxidize, so this is called oxidizing agent. So it is undergoing reduction. There is increase in oxidation state from Fe2 plus to Fe3 plus, so it is oxidation. So to balance, first what we need to do, we need to balance this electron. So into 5 into electron, these electrons cancels out. The net reaction will be MnO4 minus 5 Fe2 plus LHS. I am going to write one side, 8H plus gives me Mn2 plus 5 Fe3 plus 4 H2O. This thing is the balanced equation of using KMnO4. So I told how to do this thing. So about cell, right? About cell we have discussed in electrochemistry, right? Electrochemistry I have made videos. There I have discussed completely about cell. Cell means it contains two half cells. One half cell plus another second half cell. One will be anode where oxidation occurs, and this one will be cathode where reduction occurs. So here oxidation occurs, here reduction occurs. Total redox occurs. That is redox reaction takes place. Both oxidation and reduction take place. If you want to see this this type of reactions chemically or with the help of ice, we can see here. Take this solution of CuSO4 into 5H2O. We know that copper solution will be blue in color, right? Blue in color. In that, put that nail, iron nail, you know, which we use for hanging the pictures. So there, put that iron nail here like this. It has fallen here, iron nail. Keep it for 1 day, 2 day. You will see what happens. This iron will be in the form of Fe, right? So it will undergo Fe2 plus, oxidation takes place, plus 2 electron. Initially it will be in the form of solid, then it comes into ionic form, that is aqueous form. So it will become solution. Initially CuSO4 means Cu2 plus is there. Because of Cu2 plus only the color is blue. SO4 2 minus is colorless. This won't have any color, so it is colorless, but Cu2 plus is blue in color, right? So because of that the solution appears blue. What this Cu2 plus does is it takes the 2 electron and it becomes from aqueous, it was in solution, aqueous medium, it becomes solid, Cu, solid. That's the reaction. See here, this is the oxidation. The iron which is solid is converting into liquid. So size of iron which was solid will keep on coming into liquid, so it keeps on decreasing the size. Whereas copper which was in the solution gets that 2 electron and undergoing reduction, Cu solid. So after 1 day or 2 day you will find that this iron nail will not be there in the solution. It is like a magic, it went away. So in magicians also do use this science method only to get like see here, they will tell if I put this iron in the solution, it will be like magic will be happen, nothing, only this redox reactions take place and we will get this, right? So magicians will also do the same. So what happens, this iron won't be there, this copper was there in the solution, it falls as a solid like here. So we will get brown color copper solution here. Initially solution was blue because of Cu2 plus. Now the solution becomes, because of Fe2 plus, solution becomes green, right? So this is the change. The solid iron nail disappeared, it comes into solution. So initially solution was blue, now solution appears green. Here nothing was there, but now we will see brown color, like golden brown color. Some things will be left behind, that are nothing but copper in the solid form. This is about redox reaction. Here it is oxidation and it is reduction. So it is redox reaction. Net balance, 2 electron get cancelled. Fe plus Cu2 plus gives Fe2 plus Cu. This is the redox reaction. Reaction, if you want to write, we will write like this. And they will ask, why only iron is oxidizing, why not copper? Why copper only reduced, why not copper is undergoing oxidation? If they ask you like this, you need to tell. We know that galvanic series, right? Galvanic series. What is galvanic series? Like we have magnesium, Mg2 plus comma Mg, zinc, Zn2 plus comma Zn, Fe2 plus comma Fe, Pb2 plus comma Pb, hydrogen, H2, H plus comma 2H plus comma H2O, we can write like this. Next comes copper, Cu2 plus comma Cu. silver, copper, silver, gold, platinum. Their reduction potential 3 plus 2 comma Eg, like that. You need to write. See here. This is the galvanic series. These are arranged in the increasing order of reducing agent. As you go down the group, the reducing agent character increases. That is, these copper, silver, AuPt, these undergo reduction because their reduction potential will be more. Reduction potential is more, so they undergo reduction. So they act as good reducing agent. They undergo not reducing, oxidizing agent. They make other good undergo oxidation by undergoing themselves reduction. So these undergo reduction by themselves because they have more reduction potential and act as oxidizing agent, right? Those which undergo reduction by themselves making other oxidized, whereas these are having less reduction potential. Less reduction potential we can call it, or more oxidation potential. Since these are having less reduction potential, these will undergo oxidation. So I combined iron with copper, right? Since it is having less reduction potential, it was undergoing oxidation, whereas copper is having more reduction potential, it was undergoing reduction, right? This is the thing, because only if we combine these two, this will undergo reduction, this will undergo oxidation. And also to protect iron, how we protect iron? We protect iron by combining, we coat zinc on this iron. Why we coat zinc? Because zinc is having more oxidation potential. I mean, this is having less reduction potential compared to this, so it will undergo reduction, so it will be protected, whereas this zinc will undergo oxidation when coated with iron. It will convert into Zn2 plus 2 electrons. So zinc will be lost, iron will be protected as usual. So sacrificial protection, such things we will discuss in corrosion chapter also. So in this way we make use of this thing. And also I told anode oxidation, which cell will undergo oxidation? Which has less reduction potential or which has more oxidation potential. Cathode is one which undergo reduction. Reduction means which has more reduction potential or which has less oxidation potential. More reduction potential, undergo reduction. More oxidation potential, undergo oxidation. Reduction means cathode, oxidation means anode. These things once you remember enough, you can solve everything. About its detailedly I explained in electrochemical cell, right? Next let us discuss few more topic and we continue.